Inside each atom, there is a great battle going on. It is a battle to control the charge of the atom. There are three possible outcomes to the battle. 1. The atom can be positively charged, and therefore called a cation. Or, the second outcome, the atom can be negatively charged, and called an anion. Or the third outcome, to be Switzerland, by which I mean neutral and not charged. The soldiers for positivity are called protons. Each one has a charge of positive 1, and they amass in the nucleus, in the very center of the atom. So I'm going to represent protons with little plus signs. Here there are 6 protons amassed in the nucleus. By the way, if there are 6 protons in the nucleus of the atom, its atomic number must be 6. So we can identify this atom. What element must it be? It must be carbon, because carbon is the element with 6 protons, an atomic number of 6. So anyway, there's also an army for negativity amassing. The soldiers for this army are called electrons, and they each carry 1 negative charge, and they can surround the nucleus. I'm going to draw little negative signs to represent electrons. And remember, the electrons can be very, very far from the nucleus compared to the size of the nucleus. Here I happen to have drawn an excited carbon atom. Electrons are above the ground state energy levels, but don't worry about that until chapter 7. So now, the armies are gathered. The protons in the nucleus, the army for positivity, the electrons surrounding, or the army for negativity. Once we count their numbers, then, well, that's it. We just count how many there are. There seem to be 6 protons and 6 electrons. So it's a draw. It's a tie. This atom is neutral. No charge. A charge of 0. Because all this battle is to see who can get the bigger army. So what if there were to be 1 less electron? Then, once we count up the size of the armies, protons are winning 6 to 5. So positivity wins by 1. This would be a positively charged ion with a charge of plus 1. Okay, let's look at a different situation where negativity would be winning. If this atom were to be of a different element, say beryllium only has 4 protons. Now the army of electrons is 1 bigger than the army of protons, winning 5 to 4. But they're only winning by 1, so this would be a negatively charged anion with a charge of negative 1. What if there was an extra electron? Say an extra electron comes in and joins the electron army. Now the electrons are winning by 2, 6 to 4. So now this becomes a negative 2 charged anion. So the pattern I'm trying to show here is that the difference between the numbers of protons and electrons is the charge on an ion. And it's positive if there's more protons and negative if there's more electrons.
Made with Doodlecast Pro.